Hello everybody, my name is Reagan Brummett and today I'm going to be doing a presentation over the tissue plasminogen activator, otherwise known as TPA, and what happens during a stroke, and how TPA can save someone's life. This topic really resonates with me because it connects chemistry, biology, and medicine. It shows how a single molecule can have a life-changing impact on many individuals. So I'm sure most people have heard of the term stroke before. So the bigger question is, what is a stroke? So there are two main types of stroke, ischemic and hemorrhagic. Ischemic stroke happens when a blood clot blocks an artery. This cuts off oxygen and nutrients to the brain. This is the bigger type of strokes that occur and happens about 87% of the time. A hemorrhagic stroke occurs when a blood vessel bursts, which causes bleeding inside of the brain. This is why if an injury happens, performing a CT and MRI first before anything else is super important. But there is the key difference of the TPA, and it only works for ischemic strokes. And that the CT and MRI is done to determine which type of stroke it is before given treatment. Now we're going to go on to how clotting works. Under normal conditions, clotting is a good thing. When you get a cut on your finger, when anything happens, usually clotting with your blood is good because it stops after the injury, after you hold pressure on it. We've all got paper cuts before. When the vessel is damaged, your body triggers the clotting cascade, turning fibrinogen into fibrin. This is a sticky web that traps blood cells and seals the wound. The silent enzyme plasminogen circulates in your bloodstream. It remains inactive until it is needed to break down a clot once the healing is actually done. However, during a stroke, the same clotting process happens inside the brain. It blocks blood flow and it kills neurons within minutes, which is very bad. However, this is where the TPA comes to the rescue. TPA is a serine protease enzyme, meaning it breaks specific peptide bonds in other proteins. It's naturally produced by cells lining your blood vessels. Structurally, it contains Kringle domains, which help to bind fibrin, and a protease domain, which drives the chemical reaction. This reaction is very crucial in this process. The TPA converts plasminogen into plasmin, the enzyme that digests fibrin and dissolves the clot. Its structure is perfectly suited for the job. It locates the clot, attaches to it, and it breaks it down from the inside and out. Now I'm going to show you my iPad. And this is the diagram so you can visualize how this happens. So first, a clot will form in the cerebral artery, blocking oxygen and nutrients. TPA binds to the fibrin mesh in the clot. It then activates plasminogen, turns it into plasmin, which acts as molecular scissors. It cuts through the fibrin strands. As the fibrin breaks down, the clot dissolves, blood flow returns, and neurons are saved. You can think of TPA as the cleanup crew. It doesn't stop normal clotting, it just clears the blockage at the right time. And now we're going to talk about the clinical importance of TPA. It's sold under the name Alteplase and is currently one of the only FDA-approved drugs for ischemic strokes. It's extremely time-sensitive and it has to be administered within 3 to 5.5 hours of the symptom onset/injury. After that window, the risk of bleeding or irreversible brain damage significantly increases. We look for face drooping, arm weakness, speech difficulties, and T for time. Call 911 immediately if any of these symptoms are occurring. This can mean someone is having a stroke and you can save someone's life. Beyond stroke treatment though, TPA is also used in emergencies like heart attacks and pulmonary embolisms. This is where the clot blocks blood flow in the heart or lungs. TPA's mechanism is the same here. In conclusion, what I love most about TPA is how it represents the beauty of science working in harmony. A single molecule designed for precision and is capable of saving lives every single day. It is the perfect example of everything coming together. Ischemic strokes are caused by blockages, and TPA is the most effective clot buster we have. Its structure allows it to target fibrin, activate plasminogen, and break down clots, restoring blood flow and protecting brain tissue. It's proof when we understand molecules deeply, we can change the way we practice modern medicine, and we can save lives by doing this. Thank you, and have a good day.